This video explains how to create a molecule in Gauss view and submit it to the supercomputer to run a quantum mechanical calculation. I'm going to build monoethanolamine using Gauss view. I'll start with this carbon tetrahedral. I'll put 2 of those in. I'm not going to focus too much on how to use Gauss view. That's available in other videos or other avenues. This is mostly about just going the entire workflow through a molecule. I'm going to change this to oxygen to put in the alcohol part, and then change it to nitrogen, put in the nitrogen part. You always want to clean up your structure, and I'm intentionally leaving this one in this kind of eclipsed or boat configuration. I now want to set up my Gaussian calculation. Calculate Gaussian, quick setup. It will bring up a wizard. I want to do optimization plus frequency. I'm going to use a Hartree-Fock level of theory, low level of theory, and a very small basis set since this is an example. I'll give it a title. I like to say exactly what I was doing here, even though it's always also recorded. And then maybe something like started from boat configuration. Something that will help you with the supercomputer is if you specify the memory limit, and just do it at 1 gigabyte. That should cover most things that students at this level are doing. Specify 1 gigabyte. I'll say submit. It'll ask if I want to save. I'll click save. I'm going to put this somewhere. You'd probably want to put it somewhere on your J drive. I'm going to put it in my documents folder, and I have one set up that's called quantum. I'm going to call it MEA boat, and it will give it the file, the extension GJF when I save it. I don't want to submit it here. I could if I was running on my local Windows machine, but I don't want to submit this, so I'm going to hit cancel. I just wanted to save the file. Now I want to edit that file slightly. So navigate to wherever that was saved. I have it in my documents quantum folder. Open it in a text editor. You can use WordPad, Notepad. I have Notepad++. Notice that it gives a checkpoint file that is by default on a Windows machine, starting with the C drive. I just want to delete everything but the name of it. That's the only thing I need to do here so that when I copy it to the supercomputer, it won't have an error and not know where to place the files. Next, I want to go to the supercomputer, and I'm going to walk you through this. You'll have to bring up some terminal. There's a terminal available on the Lab Connect. Just search for terminal. I'm going to SSH into the supercomputer. It'll ask for your password. And then it's going to ask for your verification code for 2-factor authentication. This will be available. You had to set this up when you got your supercomputer account. And there's videos on the supercomputer website on how to do that. There we go. Then I'll be able to get logged in. I'm going to list my directory. There's several Linux commands. One of them is called ls or ll. They give you a long list or a short list of all the files and folders in your directory. You won't have all of these here. I've got lots of work going on, but you should have one that is no backup. That is where you run all jobs submitted to the supercomputer. So I'm going to cd, change directory into no backup. On Linux, if you tab, after you type a few letters, it will autocomplete as much as it can. And you'll notice I have nothing else that's called NO in my directory. So when I tab after NO, it autocompletes it. I hit enter. I'm now inside the no backup directory. If I list that directory, you'll notice that there's 2 folders, archive and auto delete. You want to run in auto delete. So cd into auto delete. It deletes after 15 days, 10 days, whatever the supercomputer says. And you want to move all your files before that time. The reason is that the storage in auto delete is very fast, so that calculations run very fast. Now that I'm in auto delete, you'll see I have a few folders here from things I've been running. You want to make a new directory to hold your Gaussian things. So I'm going to do mkdir, make directory. And you can give it whatever name you want. I'm going to use quantum. I'm then going to cd into this quantum You don't have to do that right now, but I'm just going to do it. And then I'm done with the supercomputer for a moment. What I now need to do is use some tool. We'll use WinSCP, WinSCP, to copy from our Windows machine on CAEDM to our Linux box on the supercomputer. So run WinSCP. That's available on CAEDM. And it will bring up something that looks like this. I already have something saved in default in BYU Supercomputer. But let's just show you how to do that. We'll click New Site. You give it the host name. It's going to be ssh.rc.byu.edu. The username, whatever you've set up for your account, and your password. I can save that as something new, something called, I'll just call it Super for right now. I'm going to save my password. You might not want to do that on a CAEDM machine. Then when I click on this, it will ask me to put in the verification code because we have two-factor authentication. If we do everything right, it should come up where you have now a connection between your Windows box and Linux. Here's my Windows box. Users, TAK, notice there's a C here. Linux just starts at /home. I had something called Quantum in my users directory. So let me go to Documents, Quantum. That's where I saved my GJF file. And I want to navigate on the Linux side, the supercomputer side, to No Backup, Auto Delete, and the folder I just made, Quantum. Now, you could theoretically have lots of other folders in here. In fact, I'm going to make a new folder. You could either do it on the Linux side or on this WinSCP side. You can click New Folder. And then I will click Directory, and I'll call it MEA for monoethanolamine. I'm going to click into that directory, and then I can just drag the file I made on my Windows machine over to the supercomputer. And now it's copied over there. If I now go over to my terminal, which is connected to the supercomputer, if I ls under Quantum, you'll see I have a new folder called MEA. And if I change the directory into that folder and list it, you'll notice that I have the GJF file. We can now submit this for running on the supercomputer. To do that, you need to load in the libraries and the executables needed to run Gaussian. So when you log into the supercomputer, it doesn't by default give you all the programs available. And so the supercomputer allows you to add in just what you need, and they do that with a tool called Module. Type the following command, and you only have to do this once every time you log in. Module load, and then we tell it the modules we want to load. You need to do G16, that's Gaussian 16. Parallel, that's something that the libraries needed to run things in parallel computing. This is a little weird one. Slurm auto array. This is just a utility the supercomputer uses to batch jobs out. And then something called gbatch. Again, you only have to do this once every time you log in. I could submit lots of jobs, Gaussian jobs after this, but you need to do it once every time you log in to the supercomputer. Module load G16 parallel slurm auto array gbatch. It'll take a moment to load. Then we're ready to submit now. This is how you submit a job. Gbatch is a special command used by the supercomputer. They created this little script to easily submit Gaussian jobs. You tell it the input file by doing -I is a flag that says the name of my input file, which in our case is meabode.gjf. You also need to give it the time, how long you think it's going to run. The supercomputer in general, whenever you submit a job, you have to tell it how long it's going to run, and it will automatically kill your job, even if it's not done after that time. So you want to give it a long enough time so you think it's going to be able to finish. You have to give it a time so that the supercomputer can kind of optimize all the different jobs that are being given. Do -T, that's the flag, and then tell it the time. 0 dash, the 0 in this case stands for the number of days you want it to run. You can give it a maximum of up to 3 days, I think, on the supercomputer. 0 dash, and then I'm going to do 0 hours in my case, 10 minutes, and 0 seconds. So the format for times is before the dash is the number of days. After the dash, you give it hours, minutes, seconds separated by colons. I can now submit this. Hit enter, and it has now submitted this job to the supercomputer. You can check the status of your job by typing the command SQ, and then your username. You can see mine's already running. It's been running for 16 seconds. This one doesn't take too long to run. If I push up on a Linux terminal, it will recall the previous commands. In fact, I can go up several times and get previous commands so that I don't have to retype. I'm just going to SQ that again. It looks like it's done. If I list my directory, you'll notice now I have a log file and an out file. The out file likely doesn't have anything in it in this case because it outputs whatever the program did to the terminal, and Gaussian doesn't write anything to terminal. It'll also have any errors that the job had. meaboat.log contains the information, the output of your simulation. You can use that using any of your favorite editors. I like VI or VIM. This is the output for the job. If I go to the bottom, it looks like this job didn't take that long to run.